Hello friends, welcome to RH Chemistry. In today's final punch Kcet 2020, I am going to discuss about first PUC second chapter, some basic principles in organic chemistry. So first we will see the synopsis, then I will tell you about previous year questions. First we will see the IUPAC name. See here, classification of organic compounds, everything I have not explained because that is very simple, you can refer. IUPAC name. IUPAC name how to write? See here, first you have to write secondary prefix, then primary prefix, root word, primary suffix, secondary suffix. This is the overall skeletal structure for IUPAC name. That is prefix, root word, suffix. That is the important order. Then you will see longest chain rule, first rule. So for all those, remember I have given some examples here. So longest chain rule, as the name indicates, so longest carbon chain should be selected here. Then how to select? See here, when I number these carbon atoms, here 1, 2, 3, 4, 5 carbon atoms are there, and here 1, 2, 3, 4, 5, 6 carbon atoms are there. Hence I can select the carbon chain as 1, 2, 3, 4, 5, 6, longest chain. And here you can say 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So I have to select the longest chain, right? So hence in selecting that longest chain, I can go for 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7 is there. So I have to go for this particular order, that is 1, 2, 3, 4, 5, 6, 7. This is the longest chain I have to select. If two chains are equal length, then remember one with more number of side chains are selected. If two chains are equal length, for example here you can say 1, 2, 3, 4, 5, 6. And the same I have number like this 1, 2, 3, 4, 5, 6. So which one is correct? So which one is correct? Remember, number of side chains, maximum more number of side chains should be present. So for that, you can see here 1, 2, 3, 5, select this, only third carbon there is a side chain. But here one side chain. But here you can see 1, 2, 3, 4, 5, 6, there are two side chain at second carbon and the third carbon. Hence this is correct, this is wrong. Then lowest number rule. So carbon with substituent gets lowest number. So two carbon chain I have to considered. See here 1 to 7, 1 to 7. Which one is correct? So carbon with the substitution at the lowest number. Lowest number you can see here. From this I have to number. Fifth carbon gets the substituent. Here third carbon gets the substituent. Hence remember lowest number is this is correct. This is wrong. Similarly, lowest set of locants rule. Carbon chain with the lowest sum of locants should be selected. Which means lowest sum of locants means here you can see in this way if I number second carbon there is a 2 substituent, hence I can write as 2 plus 2 plus 4 plus 4, fourth carbon substituent. But here you can say 1, 2, 3, 4, fourth carbon 2 substituent, so I will write 4 plus 4. Then you can see here 4 plus 2, 6 plus 2, 8 here, and here 4 plus 4 plus 2 is 10. Lowest locant rule, according to this rule, this is the correct numbering, this is wrong, remember, this is wrong. Like that. Then alphabetical order, very simple. So whatever the alphabetical order, methyl, ethyl, if it is there, ethyl you have to select first, then methyl. Functional group should be get lowest number. So functional group should have the lowest possible number in the carbon chain. Then this table I will give you, very, very important, my dear students. Note down this point. This table. Here priority table I have written the order like this only. Highest priority to lowest priority. Remember these many groups. COOH group, SO3H, COO are ester, acid halide, amide, cyanide, isocyanide, aldehyde, ketone, then alcohol, amine, double bond, triple bond, NO2, then lastly halogen. This is the order you have to remember. Then this may be present as a substituent or as a main chain. So that is depending on the priority. If COOH group is present, it is always present as a main chain, not as a substituent. Hence, always you have to use oic acid. Remember, if it is present, for example here OH, if it is present as a substituent, we will write it as hydroxy, that is prefix. Suffix, that is OL, that is alcohol, like that. Fine. So the name also you can say carboxyoic acid. Here SO3H is sulfonic acid, COO are alkoxycarbonyl alkaloate, COX haloformyl oil halide, CONH to carbamyl amide, CN is cyanonitrile, NC is isocyano isonitrile, CHO is formyl AL, CO is keto ONA, OH is hydroxy OL, NS2 is amine, double bond C, ene, triple bond ine, NO2, nitro, X is halogen. Important is this, double bond, triple bond when we have in the molecule, double bond gets first preference, that is lowest number, then triple bond, remember that. So this is priority table, so remember this. Fine. Then I have given some examples from the previous year papers, so we will solve that. So 2005 CET it was asked, this is the compound was given, so they have asked what is the IUPAC name of this. See, I have already numbered 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 is the longest chain here. Correct? So now if you name this, what happens? So chloro and methyl. So which is alphabetical order first? Chloro. So hence the name of this is 2-chloro. 2-chloro. Methyl group is 4th carbon. 4-methyl. 4-methyl. That is 2-pentene. Second carbon ene. So 2-pentene is the name. 2-pentene. Right. So this one. So start with the numbering. First preference aldehyde. Correct? So 1, 2, 3, 4, 5. So 3-bromo. Methyl and bromo. Two groups are there. Nothing is there means methyl group. Bromo. So bromo B gets alphabetical order first priority. So 3-bromo. Then 2-methyl. How many carbon atoms are there? 5. Pent. So CHO means Al. Pentanal. So pentanal. Remember. Pentanal. 2-methyl pentanal. So 2011 asked question. Like this bond line formula is given. See, this is COOH group. C double bond OH. So first numbering from here 1, 2, 3, 4. Because double bond and COOH gets the first number. Then you name this. 1, 2, 3, 4 means bute. Right? Bute. 3-ene. 3-ene. Noic acid. First carbon means not necessary to write the number. 3-enoic acid. 2012 asked me question. For all these option is given. Here I have not taken the option. That is the only difference. Now you can see two groups are there. One is aldehyde group. Sorry, this is ketone group. Because here it is CS3. Nothing is there means. If it is H, it is aldehyde. CS3. OH group is there. OH and CS3 if you compare. OH and C double bond. Out of 2, this will get the first preference. See, this will get the first preference. OH and C double bond. Hence remember, you have to numbering from this side 1, 2, 3, 4, 5. So 4-hydroxy. Because when it is present as a prefix hydroxy. So 4-hydroxy. 1, 2, 3, 4, 5 means pent. Right? Second carbon double bond. So 2-pentanone. Pentanone. Then 2013 asked question you can see. Numbering from this carbon. 1, 2, 3, 4, 5. So hydroxy methyl. H first. Right? So hence it is 4-hydroxy. 4-hydroxy. 2-methyl. 2-methyl. And pent is there. Pentanoic acid. Pentanoic acid. So this is the IUPAC name. So you have to solve some more questions. For the time being, I have solved only these many questions. This is about IUPAC nomenclature. Then we'll move to isomerism. Only structural isomerism here I have explained. Geometrical isomerism I will explain in the hydrocarbon alkenes part. First one is chain isomerism. Very simple, different arrangement of the carbon atom. So carbon skeleton will be different. Here 4 carbon in the chain, here 3 carbon in the chain, 1 as a substituent. Same molecular formula, but the structural formula is different. Position isomerism. Here different position for the same functional group or substituent. Remember here double bonded second carbon, double bonded first carbon. So same molecular formula. OH at second carbon, OH at first carbon. Position isomerism. Functional isomerism. Functional groups are different here. See here generally CS3, CS2OH, CS3O, CS3. That is ether. Alcohol and ether forms functional isomers. See CS3, CS2, CHO. Aldehyde and ketone are functional isomers. Like that cyanide and isocyanide is functional isomer. Like that carboxylic acid and esters are functional isomers like that. Then metamerism. Different alkyl groups are attached to same functional group. Either side of the alkyl group number will be different. For example, this is ether, CCOCC. So 2 carbon atom, 2 carbon atom. Here either side 1 carbon atom, 3 carbon atom. This is metamer. See here also NH. NH to that 2 carbon either side. But here 1 carbon and 3 carbon. So these are metamerism. Metamers we call it as. Tautomers. So tautomerism is nothing but different functional groups and exist in the dynamic equilibrium with each other due to the rapid interconversion from one form to another form. So different functional group will be present, but it will present in the dynamic equilibrium. Generally, keto-enol tautomerism is a very famous one. So here you can see acetone and this one OL. This is more stable. Remember, more stable is keto form. More stable is keto form. It is less stable. So this is called as keto-enol tautomerism. Here is double bond. Now what happens is this double bond will shift to this carbon and H shift to here, make it as OH. So the CH3COH double bond CH2 is formed. This is called as tautomers. Remember that. Then fission of covalent bond, two types. We know that homolytic, heterolytic. Only remember homolytic. So exactly at the center the bond cleavage take place, hence results in free radical. And heterolytic fission, so results in, remember, so carbocation and carbanion. Very simple. Carbocation, carbanion resulted from heterolytic cleavage. So because of the more electronegative element present, so here same electronegativity will be there almost. So remember, exactly the center the bond is undergoing cleavage, hence free radical is formed. So carbocation, carbanions are formed. Now we will see quickly carbocation, what is hybridization and shape. So for carbocation, remember hybridization is sp2 and planar shape, CS3 plus for if you consider planar shape. So tertiary more than secondary more than primary is the stability order. Very, very important stability order you have to remember. Carbanion, sp3 hybridization pyramidal, sp3 pyramidal carbanion for primary more than secondary more than tertiary. Primary is always more stable, here tertiary is more stable. Free radical sp2 and planar. sp2 and planar, tertiary more than secondary more than primary. So these two orders are same. Carbocation, free radical. Carbanion is reversed. Remember this. Then we know what is electrophile and nucleophile. So electrophiles are electron deficient. H plus Cl plus NO plus. It is not the thing that always plus charge should be there. So neutral also there are some electron deficient species. BF3, AlCl3, SO3, etc. And these are act as Lewis acids, remember, because electron deficient always act as Lewis acid. Electron rich nucleophile act as Lewis base. Example, Cl minus, Br minus, OH minus, Cn minus. Not only that, these are the molecule neutral one, but they are having lone pair of electron on itself. So hence remember, these are all electron rich species, nucleophiles. Then electron displacement in covalent bond. First one is three effect we will discuss: inductive effect, electromeric effect, resonance or mesomeric effect, and fourth one hyperconjugation effect. Fine. Inductive effect. What you have to remember? See, definition and all for competitive exam point of view, don't stress much. You have to understand that. That is very important here. See, permanent displacement. This you have to remember. Permanent displacement of the sigma electron, which is present only in the saturated carbon chain. Remember, where electron withdrawing or electron donating group present at one end of the chain. So, if remember, this is taken place only in the saturated carbon, sigma electron displacement, if there is electron withdrawing or electron donating groups are present. Istu nenpidra saku. Now, minus psi effect antandre, when substituent is electron withdrawing group. Remember, minus psi effect means when substituent is electron withdrawing group. Plus psi effect means when substituent is electron donating group. Very important order you can see. NO2 is very good electron withdrawing. Then Cn, then COH, then FCl, Bri, OCS3, OH, C6H5H. Order. Here, tertiary carbon, secondary carbon, primary carbon and CH3. This is the order. Tertiary is more, plus psi effect. Remember, electron donating capacity. Here, electron withdrawing capacity. So remember that. In the saturated chain, these halogens were act as electron withdrawing. But the same halogen on the benzene ring, resonance effect, it will act as a partial electron donating. Remember that. So what you can understand from inductive effect? Remember, from inductive effect, groups showing minus psi effect, acidic nature of the alcohol increases. Groups showing minus psi effect increases, acidic nature increases. Remember, plus psi effect decreases the acidic nature of the carboxylic acid mainly. Minus psi effect, if these groups are present, acidic nature will be more. If plus psi effect groups are present, acidic nature will be less. Other reverse, in case of the amines remember electron donating capacity, right? So plus psi effect alkyl group basic nature increases. Plus psi effect basic nature increases. Remember, tertiary more than secondary more than primary, like that in case of the amines. Second one, electromeric effect. Complete transfer of the pi electron, important pi electron, remember, there is sigma electron, here pi electron. Of a multiple bond towards one of the bonded atom in the presence of attacking reagent. Very, very important, attacking reagent. Complete transfer, it is a temporary effect. Remember, that is permanent effect, it is temporary effect. See, plus C effect means when electron transfer take place towards atom to which electron attacking reagent get attached. See, attacking reagent is H attached to this carbon and electron movement is also going to that carbon. Hence, this is called as plus C. Here you can see reverse. Attacking reagent attacking on this carbon, but electrons are going opposite to the carbon which is to which attacking reagent gets attached. So electron transfer take place away from that atom to which attacking reagent gets attached. Hence remember, so C, such type of compound CO minus Cn minus C effect. Not that much important for the exam. Ishtan NPT, that is enough. Resonance or mesomeric effect. See, both are same. Polarity produced in a molecule by the interaction of two pi bonds or between a pi bond and the lone pair. Very, very important. Remember, here it is only sigma bond. Here it is only pi bond, electromeric effect. Resonance effect. Here two pi bond interaction or pi bond and a lone pair interaction leads to the delocalization of the electron is called as resonance effect. Very important. Remember, plus M or plus R effect. So on benzene ring, these are act as ortho and para director. Very, very, very important. Ortho and para director. So remember. So here minus OH, that is phenolic group. This alkoxy group OR, SH, SR, NS2, NHR, NR2, Cl, Bri. This is the order of plus M or plus R effect. So here you can see this is because of electron donating capacity. So here Cl, Br, OH are acting as electron donating on the benzene ring mainly. But here in the inductive effect they are acting as electron withdrawing partially because that is minus psi effect in this case. That is the difference. Fine. Minus M or minus R. C double bond OH, CHO, COR, CN, NO2, etc. These are the meta directors. Remember, these are meta directors because electron withdrawing groups these are. Then hyperconjugation effect. Baker-Nathan effect or no bond resonance also will call it as conjugation of the electron pair of the CH bond of sigma bond, CH sigma bond with the pi electron. So here CH should be there. CH should be there. Remember, CH sigma bond with the pi electron of the double bond or p orbital of the adjacent carbon. Very important is as the number of alpha hydrogen decreases, hyperconjugation decreases, or in other way, alpha hydrogen increases, hyperconjugation also increases. See one example I have taken. So here propene. See, this is alpha hydrogen, right? Alpha hydrogen, why you will call it as this is double bonded carbon. For this is alpha carbon. Remember, alpha carbon, so alpha hydrogens these are. So here three resonating structures are possible because three hydrogen. If it is two hydrogen, two resonating structure like that. So here what happens is this bond shifted to this carbon so that this double bond is taken by CS2 to form CS2 minus. Hence, no bond will be present between this. There should be positive charge here. There is no bond present between C and H. Hence, it is called as no bond resonance. Remember that. This is about hyperconjugation effect. Mainly in toluene, it will operate. Remember, very important. Toluene hyperconjugation effect will be there. Then, purification of organic compound. You remember these many things, that is enough. You believe me. See, crystallization. Method crystallization, when you have to use, what are the examples? See, crystallization is used for mixtures with a difference in solubility of organic compound and its impurity in a solvent. With difference in the solubility of organic compound and its impurity in the solvent. See, sugar and salt. Salt is impurity. In the sugar, remember, salt is impurity, right? So sugar easily soluble in the hot ethanol because organic. Hence, the sugar can be separated from salt easily. Crystallization. Sublimation. Sublimation means the substance which will directly shift from solid to the gas. Remember, without undergoing the liquid state. Such substances which converts directly from solid to gas, you can use this particular method. Camphor, we know that naphthalene balls, benzoic acid, etc. Distillation. Liquids having sufficient difference in their boiling point. So chloroform aniline, hexane toluene or acetone. See, Andre, by seeing the mixture you can easily tell. For example, one should be, remember, volatile substance, chloroform, ethyl alcohol, such type of compound will be mixed with the another which will have more boiling point. Liquids having sufficient difference in the boiling point. Fractional distillation is reverse. Liquids having very less difference in the boiling point. Remember, acetone and methyl alcohol, very less difference are there. Benzene and toluene, very less difference, remember. So such substances can be separated by using fractional distillation. Steam distillation, steam volatile should be there. For example, aniline and water. Water is a steam volatile, 100 degrees Celsius boiling point, but aniline is, remember, it is 180 Kelvin, 180 degree. Hence it can separate easily ortho and para-nitrophenol. Because of the intramolecular hydrogen bonding, orthonitrophenol will have less boiling point, hence can be separated easily. Steam volatile substance, remember, steam volatile. Then distillation under reduced pressure. So here the liquid which decomposes below its boiling point, very important. So below its boiling point it will undergo decomposition. In such case, remember, we will decrease the boiling point of the substance by applying the pressure, under reduced pressure. So glycerol from spent lye, in the very important example, remember, glycerol from spent lye in soap industry. Glycerol can be separated in the soap industry by using this method, or concentration of sugar cane in the sugar industries can be separated by using this method. That is distillation under reduced pressure. Then qualitative analysis. First, carbon hydrogen. Carbon hydrogen can be calculated, estimated by using CuO. Remember, CuO. So when it reacts with CuO, what happens? Carbon plus CuO, you are going to get CO2. Hydrogen plus CuO, because CuO is oxidizing agent, you are going to get water. Right? So carbon from CO2, then which turns lime water milky when it is passed through lime water, that confirms the presence of carbon. Hydrogen forms water, so water turns CuSO4 blue. Anhydrous copper sulfate turns into blue color, that is a confirmation test for, remember, hydrogen. Then second one, Lasing's extract or sodium fusion extract. How to prepare? Quickly you see, organic compound is taken in the fusion tube. Then sodium metal is added and it is heated to red hot. Organic compound is taken in the fusion tube. So sodium metal is added, heated to red hot, and is dipped in the distilled water and boiled and filtered. The filtrate is called as sodium fusion extract or Lasing's extract. I will indicate it as Le. Now, nitrogen, how to calculate? See, when we calculate, so nitrogen present in the organic compound when it is fused with sodium metal, NaCN is going to form. 2018 asked question it is, remember, CET. NaCN is going to form. So that you can easily calculate NaCN plus FeSO4, FeCl3, constant HCl or H2SO4 if you add. Persian blue color you are going to get. Blue color, Prussian blue formation. What is the formula of the Prussian blue? Remember, Fe4, FeCN 6 thrice. Then sulfur. Sulfur present in the organic compound when you heat it with the sodium metal convert into Na2S. Lasing's extract, which means Na2S is there now. Sodium nitroprusside, violet color is formed. Or Lasing's extract, lead acetate, black precipitate is formed. It is indicating the presence of sulfur. And very important note that NH2NH2, NH4Cl, NH4OH, diazo compound do not give this test. Because there, especially in these three, there is no carbon atom, hence there is no conversion of NaCN. And diazo compound, remember, nitrogen immediately give rise to N2 gas. Hence, you cannot distinguish these, detect these nitrogens present in the compound by using Lasing's extract test. Remember this. Then halogen. Then halogen, remember, Na plus X give rise to NaX. Right? So, Lasing's extract plus HNO3 plus AgNO3 how to mix. If there is a chlorine, what happens? White precipitate soluble in NH4OH. If it is bromine, yellow precipitate partially soluble in NH4OH. If it is iodine, yellow precipitate insoluble in NaOH. So these type of observation you can see, that is for halogens. Note that Baalstein test for halogen, this is also possible, but it is not that reliable. Andre, you cannot believe this test easily. Organic compound taken on the copper wire. So copper wire test it is just like platinum wire what you have used in the laboratory. Copper wire you have to take, organic compound is taken, heated on the flame, blue or green color is obtained, that is presence of halogen it is indicating. Note that fluorine cannot show this particular test. Fluorine cannot show this test, remember that. Then quantitative analysis, I have given some formulas and give less importance for this in the CET because only 1 or 2 question it was asked. That too after 2012 I will show you. No question was asked on this concept. 2014. After 2014, no question was asked on this concept. That too 2 times it was asked before 2014. That too only on, remember, Geldahl's method. Only on the Geldahl's method they have asked. Hence remember, just I will revise once. Percentage of carbon can be calculated as. All these they will give. Mass of carbon dioxide, mass of organic compound, everything they will give. What you have to do? 12 by 44. Mass of the carbon 12. Molecular mass of the carbon dioxide 44. Mass of the carbon dioxide divided by mass of the organic compound into 100, you will get percentage of carbon. Similarly, mass of the water divided by mass of organic compound, they will give. 2 is mass of hydrogen, H2 here, not H, H2. Divided by 18 into 100, you will get percentage of hydrogen. Due mass method. Percent of nitrogen can be 28 by 22,400. 28 because here nitrogen get converted into N2 gas. Hence I have taken 28. Divided by 22,400. Volume of the nitrogen gas occupied in the 1 mole of nitrogen gas which is occupied. So 22,400 cm cube. Here volume of N2 at STP we have to calculate. That is by using the formula P1 V1 by T1 is equal to P2 V2 by T2. By using this formula you calculate volume. Then mass of organic compound into 100. Geltals method important, remember this formula. Percentage of nitrogen is 1.4 into molarity into volume of acid they will give. Basicity of the acid. They will give molarity of the acid, volume of the acid, basicity of the acid and mass of the organic compound they will give. Only simple formula substitution and get the answer. I will solve this question in the questions. Halogen, Karius method. Percentage of halogen, atomic mass of X divided by 108 plus atomic mass of X. Remember, if it is AgCl for example, atomic mass of Cl divided by 108 plus 35.5, 143.5 you will get into mass of AgX divided by mass of organic compound they will give into 100. Once again, least preference you give it to this particular problem, don't worry. Sulfur, percentage of sulfur is equal to 32 by 233. Mass of BaSO4 divided by mass of organic compound into 100. So here sulfur get converted into BaSO4, halogen converted into silver salt, here nitrogen converted into ammonia, nitrogen converted into ammonia. Remember this. Here halogen X converted into AgX because that question can be asked in the exam. Here sulfur converted into barium sulfate like that. So here carbon converted into carbon dioxide. Here hydrogen converted into hydrogen gas. Sorry, water. Hydrogen converted into hydrogen water. So like this. Remember this. Carbon dioxide, water, here nitrogen N2 gas, here NH3, here AgX, here BaSO4. It is enough. So this is about quantitative analysis. This completes short and quick synopsis. So now we will see questions. Previous year questions from 2020 to 2018 I have solved. Remember already I have solved 2019. If you are new to my channel, remember. So the link is given in the description box. So my first video is on this only. So 2019 paper chapter wise first PUC and second PUC I have solved separately. So go and see that. And remember, if you are first to my channel, please subscribe to my channel and WhatsApp link is given, group link is given. Add yourself to group and message me so that I will give all these the colorful material, synopsis material in the group. Definitely I can assure you, when it is a short preparation, which means whenever it is last minute preparation for the exams, remember, definitely it will help you a lot. So remember that point. Yes, previous year questions, Kcet 2020 to 2018 I have taken. And very simple question. If your synopsis is covered completely, then that too, whichever I have discussed the synopsis, that much if you know also you can solve all this question. I will show you. See, during fusion of organic compound with sodium metal, nitrogen present in the organic compound is converted into, very important, right? NaCN. NaCN is the answer. Within a fraction of a second you can solve this question. 2018. 2017. In which of the following homolytical bond fusion take place? Homolytic fusion is resulting in what? Free radical. Free radical. Remember, free radical. Heterolytic resulting in this carbocation and carbanion. So the answer is A. Very simple. Direct question. Then you see, identify the correct statement in the following. Dimethyl ether and ethanol are chain isomer. Correct? Dimethyl ether, that is CH3OCH3 and ethanol C2H5OH. What type of isomer it is? So this comes under, remember, functional isomer because functional group is different. Hence, this is not the answer. Ethanoic acid and methyl methanoate, that is ethanoic acid CH3COOH plus methyl methanoate is means CH3. Here H, methyl methanoate is means HC double bond O, OCH3. See, here these two are molecular formula same, CH3COOH. These are once again functional group is different, functional isomer, hence positional isomer is wrong. N-butane, isobutane are functional isomer. Remember, these are chain isomer. These are chain isomer. But propan 1-ol, propan 2-ol are positional isomer is correct. Because propan 1-ol is like this, OH. And propan 2-ol is like this, OH. First carbon, second carbon. So positional isomer. So the answer for this question is D. A miscible mixture of C6H6 and CHCl3 can be separated by, very simple, CH3L3, what is this? Chloroform. Chloroform having boiling point very less, evaporate easily, less boiling point, hence remember it is distillation. The fourth question, distillation is the answer, remember. IUP is the name of this compound. So this compound, how to start the numbering? See, like this, when it is given, it is 1 carbon. Start numbering from 1, 2, 3, 4, but from here you have to number because first carbon Br. So hence numbering from 1, 2, 3, 4. Right? 1, 2, 3, 4. Then remember, 1 bromo, but 4 carbon, 2 in. So the answer is A. 1 bromo, but 2 in. 2016 asked question. Then mesomeric effect involves. Mesomeric effect involves, very simple. Mesomeric effect involves, it is the delocalization of the pi electron, nothing but conjugation with the pi or pi with the lone pair, right? Delocalization of the pi electron is the answer. For 6th question, remember, answer is A. Answer is A. Acetone and propanol. Acetone, CH3, C double bond O, CH3. Propanol, CH3, CH2, CH3, CH2, CH2H, propanol. Remember, these two are what type of isomer? Functional group is different, correct? Functional group is different, hence answer is functional isomers. Now, CH bond and CC bond in ethane. Ethane is how it is CH3, right? Single bond CH3. Now, CH bond, C is sp3. This C is also sp3. And hydrogen is having s orbital. This is not having any hybridization, correct? So sp3 s in ch, sp3 and h in s in ch3, ch. Cc is sp3. So remember, answer for this question is also A. Which of the following is not true regarding electromeric effect? Very simple question. Electromeric effect results in appearance of partial charges on the carbon atom, correct? Electromeric effect will never result in the partial charge. It is always complete charge, remember, in presence of the attacking reagent. So hence, definitely which is not true, answer is A. Temporary effect wrong, it is, yes, temporary effect is correct. Operates in multiple bond is also correct. Required attacking reagent is also correct. So the answer is A. Now here, an oxygen containing organic compound was found to be contain 52% carbon, 13% hydrogen. Its vapor density is 23. The compound reacts with sodium metal to liberate hydrogen gas, a functional isomer of this compound. See here, there is a hint. What they have given, compound reacts with sodium metal which liberates hydrogen gas. And the answer is not that compound, functional isomer of that compound. Very, very important. First thing you see, ethanol, aldehyde functional isomer is, remember, ketone. But ketone or aldehyde will never liberate hydrogen gas, any of the aldehyde or ketone, hence this is not the answer. Then, ethanol, functional isomer of ethanol is methoxymethane. Ethanol functional isomer is methoxymethane, right? So, like this, ethanol, CH3, CH2OH, functional isomer is CH3O, CH3. See, the compound reacts with sodium metal, liberates hydrogen gas is correct, right? But its functional isomer, definitely ethanol is not the answer, right? Now you can see methoxyethane and methoxymethane. Two options left. What is the molecular mass? See, in case of the first chapter, some basic concept in chemistry, I have written one statement, that is vapor density into 2 is equal to molecular mass, right? What is the molecular mass of the compound then? Vapor density is 23. What is the molecular mass of the compound? Definitely 23 into 2 is equal to 46. Remember, methoxyethane formula is CH3O, CH2, CH3. The molecular mass is not 46. Molecular mass 46 ಇರೋದು ಯಾವುದಕ್ಕೆ? This is also and this is also, because these are isomer, hence it is both are having 46 molecular mass. Hence, out of these two, one is the answer. But compoundly react with sodium metal, liberate hydrogen gas. Remember, functional isomer of that compound they have asked. Then definitely compound react with sodium metal. This never be the compound, methoxymethane, this compound. So that will not liberate the hydrogen gas. Hence, if this compound is this, if this compound is this, then the answer is this. Hence, ethanol is not the answer. Now you can see Compound react with sodium metal, liberates hydrogen gas, ethanol. Ethanol react with sodium, remember, liberates hydrogen gas, forming plus CH3, CH2, ONA. Sodium ethoxide plus hydrogen gas is released. Which means this compound is this, ethanol. But answer is not ethanol because see completely a functional isomer of this compound is, they are asking, functional isomer of the ethanol is methoxymethane. Hence the answer for this question is methane. But definitely some of you will know how to solve this, but you will select the answer ethanol. But answer is methoxymethane. Read the question carefully. Compound react with sodium metal to liberate hydrogen gas is definitely ethanol. But what they are asking, a functional isomer of this compound ethanol is which one? Methoxymethane. So the answer is C here. Very, very important point. You can ask, sir, then why this is given 52% carbon, 13% hydrogen? If this was the shortcut. See, they have given this because some students will solve in other way. Because they consume more time and do that. But it is a shortcut. 23 is given, 46 is the molecular mass, then you solve. Otherwise, you can calculate in this way. I have solved that also, you can see. Here you can say I have solved that. See, molecular mass is given 46, right? So write in this form, CHO 50 to 13. 50 to 13, then difference is 35, you will write oxygen. It is not given here, oxygen. Then 12, 1 and 16 atomic mass. You calculate mole, 52 by 12 is 4.33. 13 by 1 is 13. 35 by 16 is 2.18. Then relative mole when you calculate, this divided by 2.18, this divided by 2.18, this divided by 2.18 because lowest is 2.18. You will get 1 here, almost 6 here, 2 here. So my empirical formula is C2H6O, empirical mass is 46 and their mass is also 46, vapor density into 2. So you will get 1. So the answer is this. Like this also you can do. But why you waste your time? Because we have very less time in the CET, 60 questions, 60 minutes. Hence remember, this is one of the way to calculate. So percentage is given for such students, those who want to calculate like this and those who want to waste their time. So, but we cannot waste our time, right? So shortcut is 23 means 46. 46 means out of 2, 1 is the answer. Compound which liberates with sodium metal and liberates hydrogen gas is ethanol. Functional isomer of the ethanol is, remember, methoxymethane. So the answer is methoxymethane. Then, which one of the nitrogen atom in NH2, NH, CO, NH2, first carbon, first nitrogen, second nitrogen, third nitrogen is most nucleophilic. Most nucleophilic under meaning, you know. Most nucleophilic means which can liberate the electrons very easily, which can donate the electrons very easily. Which one will donate? If that electrons does not involving in the resonance. Very, very important. Now here you can see electron present here can involving in the resonance with double bond because it is adjacent to double bond. But this nitrogen, it cannot involving in any type of resonance. Because of that reason, the basic nature of this will be more, nucleophilic nature will be more for the first one. So hence the answer for this question is B, remember. Then, Geldahl's method, 2011 it was asked, remember. 1.2 gram of organic compound on nitrogen, right? So which liberates NH3, which consumes 30 cm3 of 1 mHCl. The percentage of nitrogen in the organic compound is very simple. Directly you write the formula. Percentage of nitrogen is equal to 1.4 into. So molarity of the acid. Molarity of acid into volume of acid into basicity of acid. Basicity of acid. Basicity of the acid is 1 because number of replaceable hydrogen atom is 1 here, divided by mass of the organic compound. Mass of the organic compound. Now you solve, very simple. Correct? So 1.4 into molarity is 1 into volume of the acid is 30 cm3, right? Into basicity is 1 divided by mass of the organic compound is 1.2. Answer is, remember, 1.2 here, 1.4 here. So which means very small unit left out here. 1.2, 1.1 like that. So more than 30 is the answer. Option left is 35. So the answer is 35. 30 is not the answer. Because when you cancel this, here you will get 30 into 1.1 like that. So 35 is the answer. Then chloroacetic acid is stronger acid than the acetic acid, explained by using. Remember, chloroacetic acid formula is CH2Cl COH, chloroacetic acid, which is stronger acid than acetic acid, CH3COH. What is the reason? Because of Cl group. Cl group is, remember, electron withdrawing according to inductive effect, because here this mesomeric effect we cannot consider here. So inductive effect minus I effect will increase us the acidic nature. So answer for this question is B, minus I effect. For this also synopsis I have explained. So go and see that. So answer is B. The last question in this case, Eldal's method once again. Ammonia from 5 gram of food neutralizes 30 cm of 0.1 m acid. The percentage of nitrogen is same formula. I will not write the formula once again. Same formula. Percentage of nitrogen is equal to 1.4 into molarity of the acid given is 0.1 m this time. Right? So volume of the acid is 30. Then basicity of the acid. Once again, acid basicity is not given, means definitely that is HCl only. So 1 divided by. So mass of the organic compound is how much? 5 gram of food neutralizes 5. So hence the answer for this question is, see here, 5 ones are, so 5 6 are, right? So 14 6 how much? That is 84, correct? So 0.84, 0.1 is there. So answer for this question is, remember, 8.4 you will get. Sorry, 0.84 you will get. 0.84 you will get, correct? Yes or no, calculate. So 1.4 here. So you are going to get the 0.4 only, I think. Right, 0.84. So 0.84 is the answer. Fine. So this is about the important chapter, organic chemistry, first chapter I have considered. So remember that. Yes. If you are new to my channel, once again I will tell you, definitely it will help you. This is the only channel in the YouTube. All the previous year with the short synopsis it is explained. So if you are subscribed already, I am very much grateful to you, and share to your friends so that they will also get the use of that. Tell them to subscribe. Thank you. Have a nice day. Happy solving.